I'm Anil Kumar. Welcome to my series on limits. Now this is level 2 questions which we are discussing, especially for students who are seeking admission for excellent universities. And some of you are also taking AP calculus. It will be very helpful for those also. The question here is to find limit when x approaches 1 for sine of 1 over x minus 1. Now we are going to use the definition which Heine wrote to find such limits. In fact, we'll prove that the limit does not exist for this particular function. So let's read through these lines. For limits does not exist, we need to show that there exist two sequences, x prime and x double prime, such that limit for x prime when x approaches infinity is equal to limit for x double prime when x approaches infinity, and both are same a. Do you understand? Both these limits are same. While the corresponding functions fx dash and fx double prime do not have identical limits, right? So that is the postulate which we have. Now, how do we use it to prove that the limit of sine 1 over x minus 1 does not exist when x is approaching 1? So we have to look for conditions when the value of sine is very clearly known to us. Let's say this is our sine graph. We know that whenever the value of x is n pi, sine is 0. Correct? So that is one thing which is known to us, which is sine of n pi is equal to 0. The other thing which we also know is that it is 1 at pi by 2 and repeated 2n pi, right? So we also know that sine of 2n pi plus pi by 2 is equal to 1, clearly. That is known to us, right? So that means we know if n approaches infinity for these two functions, the value of sine n pi will be 0 and sine of 2n pi plus pi by 2 is 1, right? So what we know is that the limit when n approaches infinity for sine n pi, let me write n now, will be 0 since it is this, and the limit when n approaches infinity for sine of 2n pi plus pi by 2 will be equal to 1. Now what you notice here is that these two limits are not same, right? So above limits are not same. So do you notice that part? Now, can you correlate from what I wrote here to this? Now that means we have a function somehow. If I could write this as n pi and 2n pi plus pi by 2, right? Where of course n could have any natural numbers as its values. It could be 0 also, but we can write this as n equals 1, 2, 3, and so on, right? We find that the limit for both these functions is different. It is not the same, right? So now, working backwards, we have to look for two sequences which could give us that result from this equation. You get the idea. So we are working backwards. So what we do here is work backwards. That is how we get our solution. So how could I define my series? We can say, well, this is a set of n terms which should be giving me that result. So xn could be what? Since we have denominator x minus 1, better is to write 1 plus. So 1 and 1 will cancel, and this is in the denominator. So 1 over n pi will be a good option. And what we also note here is that the limit as n approaches infinity for 1 plus 1 over n pi is actually equal to 1. Since n approaches infinity, the other term is 0. Now what could be the other sequence? We are writing that as xn second prime. So of course 1 we have to cancel, so we'll write 1 plus something. And what do I need? I need this as 4n pi plus pi over 2, right? So I can write this as 2 over, so we just flip it, right? And write this as 4n pi plus pi, right? That is what we get, 4n pi plus pi over 2. So we just flip it and write it here. Perfect. Now that gives us the limit as n approaches infinity for 1 plus 2 over 4n pi plus pi is what? Now if n is very large, this whole number is 0, approaching 0, so we get 1. So what we see here is that the limit as n approaches infinity, this should be n, right? This should be n. As n approaches infinity for xn prime is equal to 1, and which is also equal to limit as n approaches infinity for xn double prime, which is also 1, you have shown. Correct? Now to provide the solution, we will start from here. So we'll say let the series be xn equals to 1 plus 1 over n pi and x double prime be 1 plus 2 over 4n pi plus pi. You will observe that the limit of these two series is 1 plus 1 over something, and that something is approaching 0 when n is approaching infinity, so the limit is 1. So for both we have a limit of 1. Now, for the function of x of n, we notice that we notice that limit when n approaches infinity for the function f of x prime is basically equal to 0. But the limit when n approaches infinity for the function x double prime, which is a function of n, let me write xn here, okay, is equal to 1. And these two limits, as you have seen here, are not equal, right? Are not same. Therefore, limit x approaches 1 for sine of 1 over x minus 1 does not exist. Is that clear to you? So that is how we are going to solve such questions. I hope it makes sense. Feel free to write your comments, share my videos, and also watch the other two which I am adding to this list so that you understand the whole concept. So working backwards really helps to solve such questions, otherwise it could be challenging. We'll actually have a very good application of Heine's definition in this particular example. The question here is to prove that limit x approaches infinity for sine x do not exist. Normally, we had been taking it for granted or explaining it using the diagram, right? Normally, how do we do it? We just sketch the graph of sine x and say, well, this is sine x. It oscillates from plus 1 to minus 1, right? Kind of like this. So when x is approaching very large, we don't know where it is since it is oscillating, right? So we provide an explanation that since this is oscillating, limit x approaches infinity does not exist. Correct? So that has been our explanation for a long time. And normally that's what is given in most of the books. Now the question here is to prove, we need to now prove that this limit do not exist. How will you prove it? So you can pause the video, answer this question, and then look into my suggestions. Now to prove this, I'm going to take help of Heine's definition. let's understand the definition first and then we'll apply it to prove. To prove that the limit does not exist, we only need to show that there exist two sequences. See, sine is also a sequence, right? So we need to show that there exist two sequences, x dash and x double dash, any two sequences, such that the limit at x as x approaches infinity for the first sequence is same as the limit for the second sequence, and it is equal to a, while the corresponding function's limits are not identical, right? So that can help us to prove that the limit for sine of x as x approaches infinity does not exist. So I hope the point is clear to you, right? Now with that in mind, I'd like you to pause the video and find two sequences whose limits could be same, but for the same sequence, sine of that function will not have the same value, correct? Then you have proved this particular example, right? So you have proved that this is okay. So here is how you could do it. So basically we need to choose two sequences, right? So what could be two sequences? That is a big question. Once you get that, then you can solve most of the questions related to trigonometric functions, right? So for these functions, we take a sequence which is producing us these zeros. So for sine, what produces 0 is n pi, right? So we'll take first sequence, let's say xn, as pi n, right? So that is my first sequence. The other sequence which I can take is when the value is 1, right? So that could be my second sequence. That is how we have to select the sequence. So the second sequence, let me call that as xn dash. So when is it 1? It is 1 for pi by 2, odd multiples of pi by 2, right? Or even it could be minus 1 so we could take this as 2n pi plus pi by 2. So every pi by 2, right, we could take that like this. We can say, well, let it be 2n pi, which is basically a time period, plus pi by 2, right? So at pi by 2, we are going to get the value as 1, correct? Now if you analyze these two sequences, in that case, you know that the limit for x approaching infinity for the first sequence, which is n pi, let me write xn here, is also equal to the limit as x approaches infinity for the second sequence x dash n, and both are infinitely large. Correct? Both are infinitely large. So they are both same. Perfect, they are both same. They are infinitely large. Now, let us find what is the limit of the function sine x for these two. So we'll rewrite and we'll find limit when x approaches infinity for sine of xn, which is limit x approaches infinity for sine of n pi, right, or pi n, right? So we could write pi n. Now, for pi n, whether n is very large or whatever, right? So this is n, sorry, n. So this is n, okay. N is very large. We see for pi n, it has to be 0. So this limit is equal to 0, correct? Now we could do the same for the other sequence. So the limit when n approaches infinity for the second sequence, which is sine of 2n pi plus pi by 2, is equal to what? For that sequence, for all values, we get positive 1 as our answer. Correct? Now, since these two are not the same, right, so we have to only prove that these two limits are not identical, right? So we say that the limit x approaches infinity for sine of x does not exist. Is that clear? So for solving or proving such limits, what we could do is we could take two sequences and then we can show that the limit for the function with those two sequences is not the same. If that is the case, then the limit does not exist. So I hope the concept is clear to you. Find the limit, one-side limit, as x approaches 0 from the right side for cos pi by x. So we are trying to find one-side limit here. So when I say when x approaches 0 from positive side, this is from the right side. Well, as you know, cos x is an even function, so from both the sides it is going to be the same limit, right? Okay. Now, the question here is, find the limit as x approaches 0 from the right side for cos pi by x. You can pause the video and then solve and look into my solution later to check. Now, the concept which we are going to use to find this one-side limit is based on Heine's definition. We know that this limit does not exist. Now, to prove that it does not exist, what are we going to do is we will show that there are two sequences which have the same limit, but cos of those sequences, the function for those sequences does not have identical limit, right? So that is the concept which we are going to use to solve this particular question. So we need to show that there exist two sequences, x prime and x double prime, such that the limit of x prime as x approaches infinity equals to the limit of x double prime when x approaches infinity, which is a, while the corresponding functions f of x prime and f of x double prime do not have identical limits. So this is all we have to do to show that this limit does not exist, correct? So the idea here is to find two functions which could help us solve this particular question, right? Now, if you look at the cosine function, then n pi gives you the value when it is 0. Let me sketch one. That how do we select these functions is always a big issue, right? So cosine function is kind of like this. Right. So what you notice here is that it is always 0 for pi by 2 and it will be 1 for n pi where n is 0. Right. So that kind of gives you a hint. Now, since x is in the denominator, we are choosing the functions as xn equals to 1 over 2n. Right. So when I flip it, it becomes as 2n pi. You get the idea, right? And the other function which I'm using is xn dash, which I'm taking is 2 over 2n plus 1. Because when I flip it with this, I get 2n plus 1 times pi by 2. So these are the two functions which I'm selecting, where the value of n is set of natural numbers. It cannot be 0 since it is in the denominator. Correct? Now, for these functions, what we know is that the limit as n approaches infinity for 1 over 2n is same as the limit as n approaches infinity for 2 over 2n plus 1, and both are 0, right? If n is very, very large, dividing by a large number will give you 0. So both these limits are same, correct? Now what we need to figure out is the limit of our function. Now since this is like approaching to infinity, so if I replace it with something reciprocal, I'll make it positive, right? Infinity, right? So limit x approaches infinity, since it is positive, of f of x of n. Now f of x of n is basically limit x approaches infinity of cos of, right? So this is the function, correct? So we could write this as cos of 2 pi n. X, we could write this as pi over, replacing x with 1 over 2n, right? 1 over 2n will give us limit x approaches infinity for cos of 2 pi n, right? Now for 2 pi n, we know the value for cos is always 1. So this limit is equal to 1, correct? So for us, the limit for the first function is 1, correct? Now let me shift this a bit on this side. Now let's try for the second function, which is sequence rather. So we have now the limit when n approaches infinity, this should be n. When n approaches, because we are related f of n, right, xn. So for the second function, it should be limit of replacing x with 2 over this, we get cos of n over, instead of x I'll write 2 over 2n plus 1, correct? So you could rewrite this by taking it on the top as limit n approaches infinity. So we have 2n plus 1 cos of 2n plus 1 times n by 2, correct? And for n by 2, we know it is 0. Perfect. So we see that these two limits are different, right? Since the two limits for the given function do not match, limit when x approaches 0 plus for cos of pi by x does not exist. Does make sense to you? So that is how we are going to prove it. Perfect. So many trigonometric functions you could find limit, especially you could prove that the limit does not exist using Heine's definition. That is the focus of this particular video. So I'll take up one more example, and I hope that will help you to understand how to prove that the limits do not exist, whether it is one side or like kind of both sides. Perfect. I hope that makes sense. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'll be great. Thanks for watching and all the best.